and welcome to this first, session of uh, the Voice of Glaciers Foundation's Glacier Dialogue series that we are starting. Um, I'm Anurag, from the foundation where we are attempting, to reframe glaciers not just as something that is, like far ahead, sitting, shrinking ice masses on the mountains, but how these glaciers are also shaping our rivers, the risk, the infrastructure, the migration, and just overall governance in the mountain ecosystems. So today's session, it'll ground us into the larger conversation from the lens of science, and we'll explore how glacier change is reshaping, mountain systems across the India and then Hindu Kush Himalayan region. So, just as a guideline for speakers, you know, we'll have 20 minutes, approximately 15 to 20 minutes for each one of you, followed by question and answers. And so, with that, let me briefly introduce, our speakers for the session. Uh, we have Dr. Farooq sir, who is an associate professor at IIT Indore and a senior cryosphere specialist and intervention manager at ICIMOD, based in Nepal. He'll talk about the glacier hydrology, his observations in the field, his work in the on different glaciers. And we have also Dr. Ashim Satar from IIT Bhubaneswar, who is an assistant professor there. He's known as a GLOF expert. He'll talk about the Glacier Lake outburst floods, and he's also the founder of Cryosense Lab at IIT Bhubaneswar. So, with that, I will hand over to Dr. Farooq, to help us understand how you are seeing how Himalayan glaciers are changing and what that really means for the water systems downstream and all the insights that you are going to share with us. So, over to you, sir.
Okay, thank you very much, Anurag. So I'm going to share my screen first, and please let me know when you see my presentation. So is it visible?
Yes, it is visible. Sir,
Okay.
your next slides are also visible, so probably you may want to,
Okay,
yeah.
just a minute. Yeah, so I think the next slide is not visible now.
Perfect.
Okay, so yeah. So I thought to keep the title of this brief talk very close to the name of your foundation. So the title of this talk is The Voices from the Himalaya. And so let us see what is this. So while you try to understand what is this, I would like to say that this presentation is not very technical, because I understand that there are some people who are not having solid science background. So I kept this presentation very simple, and I will try to give some messages instead of science about the glacier changes. So yeah, so this is basically the Baltoro Glacier you see, and it is actually moving. So there are lots of images, around 20 years of images every 15 days. These have been stuck together, and then we have this little video. So what we see here, that the glacier is moving from high altitude to low altitude, and it's also carrying a lot of mass. So this is how a glacier move and brings the mass downstream. And like we said that the voice from the Himalaya, so it's very interesting to know that when we started working on this glacier, you see in this slide. So we discussed with the locals, and they said, and we asked them why the glacier is named as the Rangdrung. And then they said in historical time when the people used to pass through this glacier, so they used to hear some noises, and it was like drum, 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 drum. And then this is how the name of this glacier became Drangdrung. So this is a typical valley glacier we see here. So it's also having a proglacial lake, if you can see. and it's having accumulation area that is far behind in under the clouds. But this is a typical valley glacier. For an example, if we see the overall number of glaciers, we have around 200,000 glaciers having an area of around more than zero point 0.1 square kilometer in the world. And together, these glaciers, they are covering more than 700,000 square kilometer of area. In this slide, we see these blue parts. These are showing the location of these glaciers. And towards the polar region, we have, of course, lots of glaciers because of the lower temperatures there. But we also have the glaciers, uh, you know, um, in the Himalayan range. So this is not because we have the very low temperatures here, but this is because we have high orography. The mountains are very high. So when you go up, so you have lower temperatures, and that is the reason we have glaciers in this region. So we understand that the climate is warming, global warming is happening, and here is the data since last 8 decades. And this data is coming from the instrumental records, and it shows that the temperature is continuously increasing, and the anomaly compared to the pre-industrial time is approaching towards 1.5 degree. In fact, over last 3 years, if we see the anomaly in temperature increase compared to the pre-industrial time is already above 1.5 degree rise. So that this is the current situation. And of course, that will result in several, implications will be there in the Himalaya. But let us see, compared to the global warming, how the regional warming in the Himalaya is happening. So this blue curve is showing the global warming over last 7 decades. And then we have this red curve that is showing the Arctic warming. So that is for last 3 decades, this Arctic warming is around 4 times of the global warming. So the region Arctic region is warming at a rate of 4 times higher than the global rate. If we see, the Himalayan Hindu Kush Karakoram region is also warming much faster than the global. However, the rate is less than Arctic region, but it is around twice of the global warming rate. So that means the glaciers here in this Hindu Kush Himalaya, so you can see this landscape here, panorama from Bhutan to Afghanistan. So we have around more than 50,000 glaciers. And because of this rising temperature, these glaciers are affecting, these glaciers are losing their mass. So besides the glaciers, we have also some other important cryospheric components that include the snow and permafrost. So when we talk about the cryosphere, when we talk about the implication downstream through cryospheric changes, uh, that also include the permafrost and snow covers with glaciers. So I will start with glaciers a little bit, and then I will brief about the status of snow and permafrost in the Himalayan region. So the question is, are the HKS glaciers are important? So if we see, we have Indus, Ganga, and Brahmaputra river basins. So in these river basins, altogether, we have around 50,000 square kilometer of glacialized area, and the total number of glaciers are around 54,000. So when we estimate the volume, ice volume locked in these glaciers, that is around 3,500 cubic kilometers. So that is huge mass locked in these glaciers. And we have around 1.5 million square kilometer of area that is of snow cover. So that seasonal snow comes every year and it melts out. So together with glacier and snow, so they provide the water, of course, downstream communities. Besides the snow and glacier, as I said, we also have the permafrost that is not visible from the satellite images or surface easily. So that is basically the frozen ground, and it is also affected like the glacier and snow because of warming. It has also started providing some water. So how much water is coming from the permafrost, we don't know at the moment. But altogether, these three components, they are providing water headwaters to these river basins. And in these river basins, the water is very important because we have a lot of agricultural land. So altogether, we have around 600,000 square kilometer of area that is being irrigated. The rivers, we have hydropower projects installed. So we have around 25,000 megawatt energy production. And in these three basins, we have more than a billion people. Also, we have a lot of industries. So how the HKH cryosphere is different, because at different forums we see the we see that the data is very less in the Himalayan region. It's very difficult. So let us try to understand. So these glaciers in the Himalaya, they are actually in remote locations. So often we have to drive on unpaved roads, like you can see one of the pictures from 2010 around. And then the conditions are very harsh because the glaciers are located at very high altitude. So we have to work in very low oxygen conditions. And because of this reason, we also have very limited local expertise. So the scientists, experts involved in cryospheric research are still very low in number. And that result in the data scarcity from the region. So, what are or the were major questions about the HKH cryosphere? So, some of the questions I write here. So these have been partially answered, but some of the questions are still unsolved. For instance, how fast are the HKH glaciers, snow, and permafrost melting? So we have some sort of idea about the glacier and snow melt, but we don't know how permafrost is melting. What are the climate cryospheric interactions? So we have some understanding about glaciers and snow, but again, we don't have much understanding about permafrost. What is the effect of cryosphere on river runoff? So we have some sort of idea, but the results we have, they're having huge uncertainty around them. Then we also observed recently that we have lots of extreme weather events and we have cryospheric hazards. So these climate-induced extreme weather events, how they are changing the dynamics of cryospheric hazard, that is another big question. So just to visualize how the glacier is thinning, so this is the top picture is from Kalapathar area. So the you can see we have this Khumbu glacier here, and the top picture is from 1905. The bottom picture is around after 100 years, early to the 20th century, 21st century. So these two pictures are 100 years apart, and then you can clearly see that the glacier is thinning a lot. Similarly, if we see, so many of you have been seen, I think, this picture, satellite image. So this is a Gangotri glacier that is receding continuously, and the rate is around 15 to 18 meter per year. So let us see some glacier mass changes using the geodetic method. So what is geodetic method? So when we observe the glaciers using the satellite imagery, satellite data, remotely. So that method is basically called the geodetic method. So we are observing these glaciers with the satellite normally. And there are lots of graphs. Before I explain these graphs, so let me tell you what is the unit of this glacier loss. So normally we say we use the universal unit, that is a meter water equivalent per year. So meter water equivalent per year means how much ice is melting, and that is resulting in some water equivalent. So we observe these changes in water equivalent terms. So for instance, I can give an example. At the left side, you see there is a block of ice. So that is around 110 centimeter thick blanket or a block, we can say, over the glacier. So if it melts, it will produce around 100 centimeter water equivalent or 1 meter water equivalent. So now knowing this unit, we can see that all these graphs are inverted. So that means the mass balances are negative. And these rates are different in different regions. Also, there are for each region, we have three bars, inverted bars, and three bars are showing the mass wastage between 1975 to 2000, and then 2000 to 2010, and then 2010 to 2020. And we see for over these three periods, the mass wastage is actually increasing. So let us see the glacier observations on ground. So some scientists like me, they also go on glacier and they observe the glacier mass changes using some field measurements. So we install some stakes. We also drill the glacier at different altitudes, and we try to understand how much glacier is losing or gaining over a specific year. We have more than 54,000 glaciers, but so far we have only observed 38 glaciers on ground. The first observation was started 50 years ago in 1974 on Gara Glacier. And then we started observing other glaciers. So these red dots in this map, you can see these are the location of those glaciers. So unfortunately, we don't have the long continuous monitoring. So we had these observations in mission mode. So Geological Survey of India did a lot of missions around different glaciers, and they observed some glaciers, but they stopped monitoring after 10 years or so. So the thickness or the size of the each red dot is showing the mass wastage. So bigger is the size, bigger is the wastage. So the scale says that some glaciers, they are actually showing balance or very little wastage, but some other glaciers, they are also showing very high wastage up to 1.5 meter water equivalent per year. So if we collect all these data from these 38 glaciers, so we can uh, try to see on an average what Himalayan glaciers are doing. So on this y-axis again showing the mass wastage, and the x-axis is showing the period since 1974. And there is a clear decreasing trend in mass. So if you see the average mass loss was around minus 0.62 plus minus 0.33 meter watt equivalent per year since 1974. And the trend is very much significant, and it shows an acceleration of 9 centimeter water equivalent per decade. So that means every decade we have more wastage of glaciers by 9 centimeter. So if we try to understand this data separately before 2000 and post 2000, then we understand that the mass wastage before 2000 was around 0.31 meter water equivalent, and post 2000 it was around 0.66. So that means post 2000 the mass wastage nearly doubled compared to the pre 2000 period. And many of us know that we had a very big heat wave in 2022. And particularly for that year, if we see this red curve, that is showing the extreme year. So we have some glacier observation this year, and the mean wastage of these glacier was minus 1.2 meter water equivalent. So that was so huge. Let us see what seasonal snow is doing in the HKH region. So this top panel shows the snow cover area in square kilometer, and it is differently, it is shown differently for separately for Indus, Brahmaputra, Ganges basin. So if we see the Indus basin is having huge variability or annual cycle in snow cover area compared to the Ganga and Brahmaputra river basins. So that is because the Indus part, which is in the west, receive most of its precipitation during winter time, while the Brahmaputra and Ganga river basins, they receive precipitation or snow mostly during summertime when the temperatures are very high. The bottom panel shows the trend in snow cover area over the year, and we see all these three basins, they are showing slight reduction in snow cover area. So there is a recent study we did at EC mode, and we found that over last 23 years, the snow is reducing continuously. Of course, there are some years which showed the positive anomaly, but most of the time it is negative. And for 2024 to 2025 winter time, that means the last winter, the snow was around 23 to 24% less on an average in all 10 major river basins in high mountain Asia. So that is another, uh, implication of climate change in the region. The snow covers are continuously decreasing. The third permafrost, the third component of the cryosphere. So we know very little about the permafrost, as I said, but the initial estimates suggest that the permafrost can be up to 16 times more than the glacier cover in the high mountain Asian region. So that means the permafrost, which is not visible, is probably covering more area than the glaciers in the region. So this figure shows the permafrost and glacier area in comparison. And then you see in different basins, like towards the Tibetan Plateau, we have more and more permafrost because the size of the circles or bubble is very big. So when this permafrost is thawing because of increasing temperatures, so it is actually destabilizing the slopes, and that is resulting in sometimes a slope failure. It is also resulting in land subsidence. And there are some pictures at the left side, you can see the result of the permafrost thaw. So of course, like the glacier and snow, this permafrost thaw or melt will also contribute to total river runoff. Besides, more important is this permafrost is very much linked with the hazard dynamics in the region. So I believe Dr. Ashim will discuss hazards in more detail. So I will not spend time here. So let us see the hydrology. As I said, we don't have idea how much permafrost is contributing to the total river runoff, but we have some idea how much is coming from the snow and glaciers. And the red part in each pie chart in different region shows the melt contribution, while the blue part shows the rainfall runoff or the base flow. Moving from west to east, from Karakoram or Hindu Kush region to the eastern Himalayan region, we find in general the melt contribution is reducing. And that is, of course, very much obvious because in the west part, as I said, we have more and more precipitation in the form of snow during winter time. So that accumulates during winter time and provides the melt water in summertime. While the Ganga and Brahmaputra, they receive most of their precipitation in the rainfall. So that means future climate change will affect the cryosphere more in the west side or the Indus basin compared to the Ganga and Brahmaputra river basins. So the changes in the melt runoff dynamics will appear more in the Indus basin compared to Ganga and Brahmaputra river basins. But that does not mean that the runoff dynamics will not change in Ganga and Brahmaputra river basins, because the climate is also impacting a lot the monsoon dynamics or the rainfall basically. So like if we see some studies, they suggest the future climate or the future projections of runoff in these river basins, they suggest we will have a peak water in these river basins around 2050. And then because the glacier and snow covers will reduce to very large extent, so the overall runoff in these basins will decrease. So that means we have to face first the issue of more water, how to handle it, and then issue of less water post 2050. So let us see, this is the last part of my presentation. We understand that climate is changing, and it is also resulting in extreme weather events. Like we have more and more heat waves, we have more and more extreme precipitations, whether it is a rainfall or the snowfall. So these all together, of course, they are changing the cryosphere. So cryosphere means snow, glacier, and permafrost. So this is basically the frozen snow, frozen water, we can say. So that means any change in temperature will directly impact these dynamics. And that is happening. We just saw that. And because we are in the Himalayan region, so this is very special region because it is the newest mountain range, the youngest mountain range, which is still very active. So most of the rocks we have here is the sedimentary type rocks. So the geomorphology of the region is very fragile. So altogether, this changing climate and weather extremes, changing cryosphere, and the fragile geology or geomorphology, it makes a very good recipe for for cryospheric hazards in the region. Just for a reference, we have witnessed more than 700 glacial lake outburst floods since 1833. And some studies they suggest that these will increase up to threefold by the end of this century. So why it is so important for this region? Because we also need to understand this region or the basins, they're also the most densely populated region in the world. So that means these hazards will impact the downstream communities. And a study suggests that around 10 lakh people, they live within 10 kilometers of glacial lakes. So that means if there is some disaster from these lakes, they don't have much time to react. So this is a summary of all presentation. We understand that we tried basically to limit the temperature rise by 1.5 degree compared to the pre-industrial time. That was the Paris Agreement that we already touched in 2024 and this year too, almost. But if we assume that this is the situation by the end of this century, 21st century, that is still will waste around two-thirds of the ice volume. So when the glaciers will recede, that means the two-thirds glaciers, roughly you can say, will be gone by this century, the end of this century. And when the glaciers, they are receding, they are also leaving behind the glacier lakes. Some depression, these are filled with water and the glacier lakes emerge and develop and they grow in size. At the same time, snow-covered areas and snow volumes will decrease and snow line will increase. And of course, the permafrost will, thawing will increase. So just trying to again put everything together as I discussed on the first slide, this will impact more than 1 billion people living downstream. And it will also influence long-term power generation, especially of small hydropower projects, or especially for run-of-river kind of projects. And of course, glacier retreat and permafrost thaw will increase the likelihood of landslides, glow events in future. And last but not the least, these cryospheric changes are also increasing the sea level. So there are huge implications for Asia and of course beyond Asia, because the water is also contributing to sea level rise. So we have energy security challenge, we have food security challenge, we have livelihood security challenge, and we also have the health security challenges. So I will stop here. Thank you very much. If you have some questions, I think we can discuss now, or maybe we can wait until Dr. Ashim present and then we can take the questions together. Thank you.
Thank you so much, Dr. Farooq. Thank you. This was very comprehensive and elaborate. Let's take the questions together after Dr. Ashim's session. So, with that, welcoming you, Dr. Ashim. Let's talk about the glacier hazards and gloss. Okay, over to you.
Second, thank you, Anurag. Thank you. Thanks, Dr. Farooq Azam. That was a wonderful talk and information that builds up the context for me to take it forward. I'm just trying to share my screen. Please let me know if it is visible. Do you see my screen?
It's coming. Has started sharing, but can't see anything on the screen yet. Okay, now yes.
Okay. First of all, thank you, Anurag, for such a good initiative. I'm very excited to be here. And I was really excited when you first got in touch, and when I saw something of this has started, and this is something which is very important, not only in the in context of climate change, but what is happening to the higher mountains, the glaciers, and with your experiences of what I have come across, this is very motivating for us to know your story as well, being in the higher mountains and stuck in such difficult situations. Hats off to you, Anurag, and I'm with you, and I'm sure Dr. Farooq is also with you in your journey. Thanks for inviting me.
Dr. Ashim. Thank you. Just a second. Dr. Ashim, your next slides are also visible. So you may want to change the format.
Okay.
On the screen. Yeah.
I don't know. How do I do that?
Just if you escape it and
okay.
And then just press F5 to start the presentation. Close this one. And end slideshow.
I see. Just a second.
Sure.
How about now?
No, I think it's.
Or is it okay?
No, I don't see any changes actually. It's still the same slide. Not reflecting.
No, Anurag, I think we are able to see the presentation nonetheless. I mean, it's on the full screen itself.
You continue then, yeah.
Is it okay now?
Yes, now if you press full screen, it should be okay. F5. Yeah.
How about, is it visible, the entire screen?
It's okay. I mean, we can continue. We can
Okay,
see
no
that.
problem. Sorry for that.
No,
Uh,
yeah, this is good
anyways,
now. This is
okay,
good.
this is good. Okay, thank you. I'll be talking mostly on the hazard part, but again, giving you a overall perspective, of what we have, what is going on up in the mountains. Um, and this is my title of the talk is Cascading Hazards in Himalaya. And this is a catchy title. Again, I had to keep it because Farooq kept another very fancy title. And I said, okay, let me quickly change it. And I say, when ice breaks, that's when, we have all of these disasters and hazards up there. Before I move ahead, let me introduce you to my lab here. Participants here would be interested to look what we do. We work for the mountain communities, policymakers, and stakeholders, especially in monitoring and managing the glacier hazards up in the mountains, especially in the Himalaya. The broad expertise we have, I would not like to go in detail. We work for the hydropower sector, early warning systems, GLOF modeling, avalanche, and machine learning algorithms, GLOF processes, and so on. Where do we work? We work worldwide in different places wherever there is glaciers. So, especially in the high mountain Asia, you can see here, we work in the just a second, I cannot see the pointer option. Okay. I work in the high mountain Asian part here, mostly where it covers countries like India, Nepal, China, Bhutan, and of course, working on Peru. I've been working in Swiss Alps even now, and then also parts in Iceland. So this is our reach in glacier hazards in different universities. In India, we normally have covered the entire Himalayas, where we try to look into different themes like glacier hazards, and we spread across looking into these hazards from Jammu and Kashmir to Arunachal Pradesh here, with multiple national collaborators. Well, when we talk about Himalaya, the first thing comes out is this very scenic view with beautiful sunrises and sunsets. We normally go there uh, for recreational purposes where we try to enjoy. But again, this might sometimes look like this, where they are termed as the hills of tragedy. So uh, why do we term relate such a beautiful place with such a very different term which is related to tragedy? This is because of some of the incidents that we've seen over the past years, especially with the events that have severely impacted humans and infrastructure, leading to economic loss and damage, also causing psychological impacts for a longer period of time. On my screen right now, what you see is the Kedarnath settlement that was before and after the event. You can see here, this was the 1965 limit of the Kedarnath settlement in yellow, and you could see that what happened in the 2013 Kedarnath cloudburst with the glacial lake outburst flood of the Chorabari Lake. This is what makes us a little bit concerned about the energy that these events have that can completely wash away settlements. Coming back to what Dr. Farooq already mentioned about distribution of glacial lakes and permafrost, some things which we are looking at, and they're widespread in the world. But when we look into the Himalayas, they're even more widespread because of the regional extent of the Himalayas. Again, I would not like to highlight here, Dr. Farooq has well explained about the ongoing climate change global warming, what we see is that if you look into the temperature anomaly, when we compare the temperature before the pre-industrial times, we see that these are the simulated temperature of 2 degrees and 4 degrees. We can see that the land portion is going to heat more in the future, which means that glaciers definitely are very, very sensitive. Even now that we know, it's going to be even worse in the coming days if we do not take the right steps at the right time. Well, the question is, what happens to the meltwater that is coming out of the glaciers? Well, you can see that these glaciers have been showing a lot of mass loss over the years. And the mass loss has been converted from solid to liquid. And the liquid water is basically going to two sources. One is it is leading to sustainability. That means it is going to the river systems, especially in the Himalaya. We can see the Indus, Brahmaputra, and the Ganga water systems. If it does not find its way to the river systems, it has either been trapped up there. It is trapped there in the form of glacial lakes. They did not find a way out of that source and was very near to the melt source, and they form lakes like this. On the right, you can see this is how they form. Well, there are thousands of lakes spread across the Himalaya. Which ones to look at? Can we target all of them? What's the way forward to go ahead? We can have a discussion on that maybe soon after the talk, but yes, that's a question that all of us should think about. Well, we know in simple terms, glacial lakes are nothing but a tsunami happening at higher altitudes. So we have heard about tsunamis from the ocean. Just imagine a tsunami coming down from the hills. That's what we see in a glacial lake outburst floods. And this tsunami is not less than the energy that we see from the oceans. They can wash away an entire settlement, like we see in the coastal areas. And that's why we are very, 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 very concerned about. Coming to what Dr. Farooq mentioned, how much of the population is exposed to GLOF is a question. And if I say you that the numbers are already here, and what we see that approximately 14, if you look into the people exposed in GLOF, I would like you to look into this slide and compare our Himalaya with the other mountain ranges. This is the high mountain Asia, where India also lies, and you can see 32% of this entire GLOF exposed people are exposed to glacial lake outburst flood. This is the biggest pie chart you can see in the entire world. But what is interesting here is this green color bar plot tells you how much of the population is exposed, how far away from the source. You can see within 5 to 10 kilometers in high mountain Asia, we have exposure of people. That means people are closer to the source of danger. That is the hazard itself. If you compare it to the other mountain ranges in the world, that's something which is very striking in terms of high mountain Asia, where India is also located, where Himalaya is also a part. Now, coming to this is a very interesting lake. I would like you to pay attention to this. As I said, I would give you perspective as which would be useful for a layman to understand. I'm assuming all of you are laymen today here. And let me give you a perspective of what we are talking about, the scales we are talking about. This is the biggest lake in the Himalaya. This is called the Lower Baru Lake in Nepal. And it is known to be the deepest lake of the Himalaya, holding a volume of 112 million cubic meters of water. Now, if I tell you how much it holds, 280 swimming pools, Olympic swimming pools. You must have all seen a swimming pool. Just imagine 280 swimming pool into one lake. That's the amount of water this particular lake carries. So now I think when you relate swimming pools to glacial lakes, it's 280 number of swimming pools in one lake. That gives you a perspective of the amount of volume of water. coming to the depth of this lake is 205 meters deep, and this is the Kohinoor Square Tower of Bombay. This is located one of the skyscrapers in Mumbai. And if you see, you can submerge this building, into, this is more than a 30-story, I think it may be more than 30-story building that can be submerged into this particular lake at the deepest point. So I'm sure now you get a perspective of the depth as well, along with the volumes, right? So imagine a tsunami coming down with this much of water all the way in steep slopes and striking these, infrastructure and people living in the valleys. What we have witnessed has given us lessons that we learned from them. But how do we go ahead with all the lessons that we have learned from the past events? So these are some of the events that I would like to highlight. Majorly the Chamoli disaster, the Kedarnath disaster, and many other which were transboundary in nature. But more strikingly was the event on the 3rd and 4th of October 2023 in Sikkim, they're broadly known as the Sikkim floods. Let us see what happened. And since I would not be able to go into details, but I would be happy to give you a layman perspective, so that we end up on a question where we are all looking for answers. Well, on the 3rd and 4th of October 2023, a devastating flood hit the Teesta Valley in Sikkim that led to the entire valley to go through very hard times, especially the Teesta 3 hydropower, which was completely destroyed. And what was found out from one of our papers and several other papers, that it was because of a failure of a moraine in the form of a landslide that went into the lake and released 50 million cubic meters of water in no time. So that is the amount of water that came out of the lake. And you could see some of the photographs that the lake level dropped by 28 meters on an average. You could see here the pre and the post lake marks, and this was the drainage of the lake. How much water did it come out? 20,000 swimming pools of water came out of South Lonak. This is one swimming pool you are looking at my screen. And just multiply the amount into 20,000. That amount of water came out of the South Lonak Lake. And now you know what energy that had, that it kind of eroded a lot of sediments along its way, deposited downstream, causing buildings to submerge within that transported sediments. And now I'm going to give you a perspective of how much was the debris. When you try to take the debris and fill it in swimming pools, how many swimming pools do we have to fill up to quantify that amount of sediments that this particular event transported? Well, I've skipped this slide. This is just to show that this moraine was moving from before, and we had to look at it after the event happened, but we saw that this moraine was moving from past before this actual event happened. Coming to how did we know about the timing of this event? Well, they were all captured by seismometers, mostly because they were put on place to look into earthquakes. But surprisingly, these seismometers were well aware, were able to capture this bigger event with great magnitude. And you could see that, these signals were captured by the seismometers, and the exact timing of the failure was known. Now, looking to the pre and post sediments, the disaster that happened, you could see here buildings submerged up to the ground floors are completely buried under the transported sediments, deposited sediments. And then look at this picture, which kinds of, gives you, how much energy this particular event had of transporting such huge volume of sediments down to hundreds of kilometers downstream. Few more visuals from soon after the Glough event. You could see here, this is the first floor of the building. The ground floor is completely submerged under sediments. Where did this sediments come from? How much was the volume? Again, let me give you a layman perspective to that. This came up from the hills up in the Tista, where there was a lot of lateral erosion, a lot of lateral cutting because of the water energy from the water that came down. 108,000 swimming pools, you have to fill it up with sediments to account for the debris that was transported. 270 million cubic meters of volume of sediments. You have to fill 108,000 swimming pools with that volume to account for that particular amount of debris. Now you get a perspective about water and also the debris that got transported during this event. The debris which got transported during this event was in order of magnitude higher than the lake's water that came out, 50,000 cubic meters of water. This gives you a perspective of how big energies that these cloughs can have with, energies that can erode and transport, mobilize sediments. So this is not just water we are talking about. We are talking about concentrated debris flows. Well, it's not over. A glough happens, and glough has long-term implication. What happens post-flood? You could see some of these. The bottom of the river was uplifted because of the sediments that got deposited, and the subsequent monsoon, you could see flooding. There was not enough space for the monsoon water to be accumulated in that valley, which was initially made for that. Now that we have so much of deposits underneath that it is not able to hold the monsoon water, and then we have these post-glough implications. These are some of the hydropowers impacted. You could see pre and post images showing the completely shattered and destroyed Tista 3 at Chungthang. Well, this is again something interesting I would like to highlight about how numerical models, scientific studies can help you in identifying these high hazard zones. This is a paper published in 2019 when I was doing my PhD. And this was for the same Tista Valley, and I simulated the South Lonar Glacial Lake outburst flood, and that gave us, some perspective of where is Chungthang located in terms of its hazard zone. And you could see that, the Chungthang was located in very high hazard glough zone, and it was in 2019 that, kind of the motive of this slide is to highlight that scientific studies can help us in one way to find out these hazard zonations in terms of cloth. With a last few couple of slides, I would like to highlight upon the concept of hazard, exposure, vulnerability, and risk. So these are well-known terms, but they're well confused. Well, when we are trying to look into these terms, we often get confused and try to use them interchangeably. Many a times, we try to relate hazard with risk. I'm at risk, he's at risk, the building is at risk. I'm going to give you some example of that today. Let me look into this very interesting slide. On the left, you see danger, electrical hazard. You must have come across these boards when you walk by the road. This says electrical hazard, which means that it can be of harm to you, if you touch it, right? It only gives you a warning that it has potential to cause damage in terms of electric shocks, right? So that's an hazard. Unless someone touches it, there is no damage. That's an hazard. It has potential to cause damage, but it has not caused damage until there is some exposure to that, right? Unless you touch the electrically bodied fence, you get an electric shock and you get the damage. On the right, I try to give you the example of vulnerability. out of these two people, I can see on the left, there's this person holding with well-suited clothes and taking an umbrella in a rainy season. On the right, we see a guy who has no umbrella, and he is also not well dressed. But if I ask you the question, who is likely to fall sick in this situation? So an obvious answer would be the guy who is well dressed, who has an umbrella and is protected from the rain, isn't it? So I would say, the answer can be something else. I would say the other guy would be safe. There's also chances that the other guys also would not fall sick, whereas the guy with the umbrella might also fall sick. That's because of the immunity. If the other guy has more immunity, the conditions that has led to the hazard situation is now minimized. That's where we balance exposure, vulnerability, hazard, and quantify risks. So it's a very complicated term. And I'm sure with this small example, I'm trying to make the concept a little easy. But again, this is a little more complex, as I say. Let me give you an example of back to Kedarnath. This is a pre and post image. What you see here are buildings that were destroyed in different colors. The red ones were completely destroyed, whereas you can see a few red buildings which were completely destroyed in middle of some buildings which were partially destroyed. Why is it that these red buildings lied between these buildings which were not destroyed? That's because they were vulnerable. They were made in such a way, or they were in a state that energy could destroy them. And these other buildings, even they were exposed, they were resilient. So that's the point. We bring the concept of resilience here, whether it is personal resilience, whether it is infrastructure resilience, social resilience, that should come into the whole risk perspective. Now, the main thing is adaptive capacity. We often try to neglect this. When I say adaptive capacity, I'm trying to highlight upon the resilience, which kind of reduces the risk. So you can see here, exposure and sensitivity increases the risk, whereas adaptive capacity reduces the risk, right? So that's very important, that whenever we're doing risk studies, we also need to take community into account, look into their adaptive capacity, look into how vulnerable they are, look into a state of risk in which they are in right now. That gives us a true representativeness of the risk at that moment. Well, I'm exceeding time. I have another meeting, but again, I'm going to skip a few slides. But the last two slides is about how do we reduce the risk. There's some good example. You just put in a pipe into a glass, suck the water in using your mouth and let it go. With the hydraulic gradient, lets the water move out. So such interventions are done in Sikkim, where glacial lake water was drained. When I see this, that these are potential measures to reduce risk, I would not like to neglect upon the non-structural measures, which is spreading awareness among people. Spreading a spread of the word glove. How gloves impact societies. How do you react to glove situations? All that awareness can significantly reduce the risk if they know. We from our childhood in our schools, we were made, we used to drill for earthquakes, we used to do those drills. Do we have such drills for glove or flash floods? Or can it be a good solution for the high mountain community? So I think that's one way to go ahead.
You, Dr.
And then with the last slide, I would like to stop upon this particular thing, which is the Nepal's first hydropower from glacial lakes. Glacial lakes are not always dangerous. They can have some secondary benefits. Now, can we make up electricity without electricity in the mountains? And this is an example from Nepal that the first electricity hydropower has been built in the Himalayas, giving electricity to 120 households. Well, with that, I would like to stop and on behalf of my teammates and my lab here, I would thank for this opportunity, the Voice of Glacier Foundation. Hats off to you, hats off to Anurag, and thank you for all who have joined us today.
Thank you. Thank you so much, Dr. Rashim. Very, very enriching presentations from both of you and Dr. Farooq and both you. And is Dr. Farooq also here?
Yeah, I'm here.
Okay, great. Yeah, so I think this is brilliant. Thank you again. I know we have started little late and it got little extended. But with that, we have a couple of questions on the chat for I think all of you. From few questions from my side, but also there are questions from other participants. Mohammed is asking, I'm a student of remote sensing and GIS applications, and why the glaciers are receding rapidly on the Indus side compared to Ganga and the Brahmaputra. And general question for both of you. Which skill should be learned to a remote sensing student who wants to do the research in the cryosphere?
Okay, so yeah, so I don't think the glaciers are receding faster in this basin than Ganga and Brahmaputra, because a big portion of Indus includes Karakoram range, where the glaciers are quite stable, at least over last 30 years, 40 years. However, they have started wasting their mass recently over last 5, 10 years. So I'm not sure why. Maybe from my slides this message came somehow, but no, I think it's not like that. So the glaciers in this basin, they are not receding faster than other basins. Also, important thing is maybe we have some specific glaciers in each range, mountain range, which may have like low wastage compared to the other glaciers in the same range or other range. So that does not mean the glacier of that region is wasting less mass. So so we have had to quite heterogeneous behavior of the glaciers basically. So in each basin we may have different glaciers having different mass balance behavior.
Mm-hmm.
So difficult to say. Um, the another question I can see here is general question for both. Which skill should be learned to a remote sensing student who wants to? Okay, okay, I missed the question. Who wants to? Can you please read?
Yes, I will. I will read.
Okay, I cannot see more than
The
who
question
wants to
is,
do what.
which skill should be learned to a remote sensing student who wants to do research in the cryosphere?
Okay, so if we see around 80 to 90% of the experts, scientists, or the young enthusiasts for cryosphere, they are having remote sensing background, right? So of course they know the basics and the skills they should have to investigate the glacier or cryosphere using remote sensing tools. But it is, I think, extremely important, which is missing in this part, to have some experience on ground as well, whether it is the remote sensing experts or the modelers who model these cryospheric changes. So they should now and then go with the experts who are going on glaciers on ground, trying to understand the things or observing the cryospheric changes on ground, so that they have better clear picture. Because it's, if you see the glacier in reality, it looks quite different than the glacier you see through satellite data. So it's better if you invest some time on ground as well.
Thank you. There is also another question that for Dr. Ashim, can we consolidate the unconsolidated loose sediments of terminal moraine of Gloff Lake? And
Mhm.
and then there is another question: do we have plans to conduct research in Arunachal Pradesh? I've noticed that only a limited number of studies have been carried out in that region.
Thank you. Thank you. I think these questions are important and also interesting. That the fact is that we cannot consolidate something which is already unconsolidated. The point is that we should look into the concept of permafrost. This is frozen or at least consecutively of 2 years. This is the basic definition. And permafrost research has been really limited in India. And when we talk about frozen ground, these moraines, they show structures which are, which are depicting permafrost. So also in South Lonak, which we saw. And as they degrade, when they're exposed to, over 0 degree, seasonally or over a long term, they try to degrade. When they degrade, they lose their integrity and they try to fall off. And that's what is one of the major reasons of debris flows in the high mountains. So consolidating that is not a possibility. But again, the only solution is to stop this positive feedback cycle of permafrost degradation, right? So once we can slow down the process, the unconsolidation that is happening or degradation can be slowed down. That's the only way we can think of our future. And regarding the research in Arunachal, we have a project in Arunachal. We are planning to go this year in the month of April. Supratim Guha, please, I think you also have my phone number. I also have yours. So we can connect through phone and coordinate our Arunachal visit together.
And so can we say that like permafrost is the most under-discussed glacier-related risk in the Himalayas right now, today?
Well, yes, with the recent IPCC reports and what we have known from the global studies, we definitely know that there is something going on with permafrost, but especially in context of Himalaya, I'm not sure. Dr. Farooq is doing some work. Dr. Raj Ramshankaran, Irfan Rashid from India, they're doing some work. They've installed sensors to look into monitoring. Mohammad Wani is there, who is doing some work, great work. But whatever the work is done, it's very, 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 very limited to a spatial extent. I must tell you, that is actually not even 0.01% of what we have known or what we are yet to know. There's a lot of hidden things that needs more observations. That is something which is under researched, and we are going towards it.
Maybe we should plan a session around permafrost in future, bringing it.
Yeah, I think Professor Farooq would be a better person here because he's an expert in permafrost, and he has seen a lot of permafrost when he's been last 20 years in the glaciers.
So yeah, so permafrost is something which is least explored in the Himalaya, especially. And how much we know about permafrost, we can say we know about permafrost to the same extent that we knew about glaciers 50 years ago. So it's just like we are just starting the permafrost research. So what we know now from the satellite, mostly we have the probability maps. And then these probability maps we have to check with the ground.
Sorry to interrupt,
research.
Professor Farooq. Anurag, I have to leave. I have another meeting.
Sure.
So thanks for inviting me. And
Thank you for your time.
It was great listening to Professor Farooq. I normally talk to him every day. So that's a different thing. So he has been a mentor to me. Of course, very, very supporting. And Anurag, great for this initiative. It was a pleasure being here.
Same here, my pleasure.
Yeah.
Thank you. Thank you.
Yeah. See you. Bye-bye.
Bye, Dr. Hashim. I have another question, Dr. Farooq. Are we really considering when these hydropower projects and infrastructure projects are getting planned and designed, are we really looking at GLOF-related risks or, into it, considering in it, or is it being ignored?
Yeah, probably we are ignoring the future runoff in these river basins as well as the possible hazards. Like we had this Sikkim disaster that happened in October 2023. Hashim discussed about it. And now they are rebuilding the same hydropower. And the lake was partially breached, not even to half. So the danger is still there. Maybe another perturbation comes, maybe some landslide, earthquake, or anything else that can trigger the burst, again, we will have the same situation.
Got it. Thank you. There is a question that in an event like Chamoli 2021, how much the hanging glaciers are vulnerable to glacier hazards? If yes, then how to quantify or consider them?
Okay, so that is something we don't know much about. We have hanging glaciers, and in Chamoli, we investigated it thoroughly, and we understood that these kind of areas uh, are also affected by warming, and this is one thing. So warming can it destabilize the bedrock itself, right? And also Chamoli kind of disasters may also be because of the long-term weathering process. Because where the glacier is residing, so it is on some rocks and they are weathering. So this is another possibility. And um, beside these, I think the area is also tectonically very active. So even if climate change is not happening, at some point of time, there will be, disequilibrium with this mass, held at some point and the gravitational pull. So we will have landslide if there is no, external factor playing just because of tectonic activities, because it is actually dynamic. So we don't know exactly, but what we can do actually, we learned that there are some slopes in the same valley. We had similar kind of events before Shamoli, but unnoticed at a smaller scale. And now what we can do, we can map all these areas and then develop some zonation maps. And we can say, okay, we have these are some hot spots where we may have some mass movement or the failure of the hanging glacier. So that can be done.
Got it. Thank you. There is another question from Shreya. With projections of increasing GLOF risk, do you think early warning systems are keeping pace to alert communities with the rate of cryospheric change in Hindu Kush Himalayas?
Okay, so that is another area where we have to improve a lot. Currently, we are developing some early warning system, and I have worked in the Alps with early warning systems back in 2010 or 12 with my French colleagues. It is quite, underdeveloped at the moment. This is the first thing. So we need to invest, of course, a lot of, we have to do a lot of R&D to develop area-specific early warning systems. Of course, efforts have been put over last some years. The another issue which Ashim highlighted nicely uh, is we live very close to these areas. So if there is some siren, for instance, we have very limited time to act. Like if you have seen the video of Dharali, right? So Dharali trigger point was around 8.5 kilometer above this Dharali village. And within 30 seconds, somebody was shooting, if you have seen that video. Within 30 seconds, the whole village was like gone. And you could see the people like, you know, uh, they just they were buried in this flood. So we have very limited time because we live very close to these hot spots. So I don't have a solid answer to this, but yes, we need to invest a lot in early warning system, and at least it can give us maybe a couple of minutes, and then we have to train the local communities how to react. If there is some siren, how to react. So we have to develop those kind of plans in some areas which are very fragile, sensitive, and very vulnerable. We can also think of shifting the
Community.
population.
Got it. Thank you. There's the last question, I think. After that, let's close it. What are techniques to mitigate the GLOF events? Because large number of glaciers are not under observations and at limited time extent, how do we mitigate these hazards?
So one thing is we have to map these lakes. I have suggested already several times that every 5 years we need to have the inventory of these lakes so that we understand how much volume is there logged in these lakes. And then there are some, of course, criteria. Using those criteria, we can decide which lake is potentially dangerous. So we map them regularly. We also check if they are potentially dangerous or not every 5 years, or maybe you know uh, earlier than 5 years, like 3 years or 2 years, depending on how much we can invest. Then focusing on some potential dangerous lake, we can plan our early warning systems, maybe migration. We just shift the population, and especially if we have some planned hydropower project. So we consider this potential danger from these lakes before we start the development of the HPP. So
Thank you,
I
sir.
think before you close it, so I have shared a link of International Association of Atmospheric Sciences website. So there, I request all of you to join it as a member. It is free, and you will be actually getting some monthly newsletters that will provide the information what is happening in cryosphere globally. So I think we need to have more representation from India. So I request all of you who are not the member of IX already, so please take that membership. And thank you very much, Anurag. It has been very good. I really enjoyed it, the presentation from Ashim as well, and the questions. So there are some questions which are not answered. So I am going to share my email. If somebody wants,
Yeah,
you
that
can just write me your questions, and I will try to answer as soon as possible.
no, thank you so much, Dr. Farooq.
Thank you very much.
Ashim, it was just so enriching. I learned a lot, and we keep, coming back to you for your guidance and with our questions. So thank you once again for your
Thank
time.
you.
And thank you so much, everyone, for joining. We look forward to reach out to you for the next dialogue. We are still contemplating which should be the next focus area we should pick for the next dialogue. So stay tuned, and we'll keep updating on our Instagram and on social media on LinkedIn. So please follow the Voice of Glaciers Foundation there, and so that we'll reach out to you. Thank you so much.
Thank you. Bye.
Bye bye.